So now in this video, we're going to start off with an emitter follower circuit. So if you study transistors, you see this all the time. You want a voltage out of a transistor. One way is you can set a voltage with, in this case, a voltage divider, a 10 kilo ohm trim pot wired as a voltage divider. We have about 2.6 volts. So that voltage is going to the base of this NPN transistor. It's a 2N2222. So at the emitter, we have that voltage minus the diode drop of the base to emitter. So unfortunately, we have to account for about 0.6, 0.7 volts in that range as a diode drop. We will increase the voltage and look that it still holds true. That so we got 4.18, so 4.2. So if you take away 0.6 from that, it will be about 3.6 in that range. It won't be spot on, but there you can see a little less than 3.6. So we lose a diode drop. Looks like we lost about 0.7 volts. So in any case, there is a pretty simple fix to compensate that I came up with. And I'm sure a lot of other people did, but I haven't really found this lately. I found it when you have a push-pull configuration. So you got an NPN transistor amplifying the current, taking the voltage, but amplifying the current from a positive voltage, and then when it swings negative, you have a PNP transistor amplifying the current for a negative voltage. But in any case, we have here a 10 kilo ohm resistor. I'm going to put to the positive rail and then to the base of the transistor right there. So what that's doing is the power is on. I'll turn it off. Should always turn the power off while you're wiring, but sometimes you notice interesting things while you're wiring too. But in any case, we have that to the base, the middle pin there. So that's coming from the positive rail. So now it is always getting a charge, and we're going to take a diode now. And we are going to wire it with the anode to the base of the transistor, the cathode over here. So we have a positive charge coming there, headed towards the trim pot. This is 5 volts, and the trim pot is usually lower than 5 volts. So there's a voltage difference. It's pushing on it. But in any case, let's see what the result is. We will turn the power on. And at the output of the trim pot here, oh, the power's off, that's right. We have 4.2 volts right there. So now, let's go to the output of the transistor there. And there you can see it is, it's not 4.2, but it is a lot closer. And I'm going to turn down the voltage, and so there's probably better ways to wire this to get it more accurate, but in any case, for the most part, we mostly eliminated that voltage drop. So there you can see 3.2 coming out of the trim pot, and it's about a volt less, or 0.1 volts less right there. So we eliminated most of the base to emitter drop. Let's go lower voltage. And a 10 kilo ohm resistor here might not be the best. That might be one way to make adjustments. And so 2 volts in, and again, looks like 0.1 volts less. So especially if 0.1 volts doesn't make a difference, but 0.6 or 0.7 would. This is a pretty good setup in my opinion. So in any case, hopefully you found that interesting. Hopefully I can make a future video where I go into more detail and better strategies for building something like this. But so far it's fairly effective, so I like it. So thanks for watching. I will see you in the next video.